So last time we saw that given a pair of numbers where the first one is less than or equal to the second one, if it's greater this thing throws, then we get a category. Right? We can write this hum function or hum functor that takes these pairs of less than or equal to's and composes them and gives us the transitive property of the relation. And similarly for div and div hom. Right? If 3 divides 6 and 24 divides 96 and 6 divides 24, then 3 divides 96. Any partial order will give us a category in this way. But the nice thing about this is that we can look at one of these things and pull out the source and target of this arrow. Similarly here. And the way that we've currently defined our category of contracts and guarded functions doesn't let us do that. And we'd also like to be able to talk about categories in a more formal way, have them be JavaScript objects of some kind. So we'll introduce this notion of what a category is. A category takes a contract for the morphisms. Now, we don't lose any information that way because the objects we can think of as the identity morphisms. So all we need to know is what a morphism is and how to compose them. So in this, what we're going to have is an object with two properties, C and C hom, where C is a function, it's a contract, and C hom takes a before and after and returns, oh I got this one wrong, hom C comma C. There we go. And returns a function that expects a middle and produces the composition of it. Okay? So we immediately get the two categories we talked about yesterday. Let's make sure that this passes this contract here. LEQ hom, well let's do div because it's closer. So div hom here expects something that passes the div contract and something else that passes the div contract, and returns a function where it expects another thing that passes the div contract and produces something that passes the div contract. So yes, we've got the signature right. Okay. So now we have less than or equal to and div, the two categories formed by these relations, these transitive reflexive relations. In order to cast our category of contracts and guarded functions into this form, we do this. Say a guard is a triple consisting of an input contract, which has to be a function, an output contract, and a function that goes from one to the other. Okay, so given two of these triples, we get a function back that expects a third triple, and we pull out we have to do return, here it expects a triple out. So this should be return before 0, after 1, and composition of the functions. There we go. So it returns one of these triples. So for instance, say we had, say we're using that repeat function that takes in an integer and produces a string that's the concatenation of the digits of the integer. So here we'd have int32 and str and this function repeat that passes this hom thing here that we've put in. So then when we went in to use it, we'd have some function that gives us an int32, it outputs an int32. Well, let me just do this explicitly. So we have var repeat, hom, well, that'll be, this will apply the hom to it. So we could do it again, but that would be overkill. Function, and return then we want something that gives us an integer. And then something that takes a string. Okay, so now to make guarded, these are just plain old JavaScript functions. Now we want to make guarded functions out of them. So we want to invoke the guard function. Well, repeat takes in an int32. Spits out a string. There we go. So now we have one of these triples where we can see what the source and target contract are, as well as we have the function that goes between those. So var glen function, oops, is guard. And we're going to expect an array and produce an int32. And the function is len. Var quarter function, no, is a guard. This takes in a string and produces a number. So now I can say guard hom glen quarter repeat. Right? So what's that going to do? Well, glen goes from arrays to int32s. The middle one, grepeat, goes from int32s to strings, and the after goes from strings to numbers. So the result of this thing had better go from arrays to numbers. And so what we see here, before 0, before was glen, so that's array, and after 1, quarter is after, 1 is num. So good, we've got that right. And then this says compose all the functions. Do len, and then repeat, and then quarter. So we've got that one right. Okay, so now we have a category, guard, whose morphisms are guarded functions, and this is how to compose them. Here is something for monoid homomorphisms. Give me a triple where the first one, just as before, these two are contracts for sets of values. Here the first two need to be contracts for monoids. So this says that the first one, the source, should have a set of values, a multiplication that takes two elements of that set and produces an element of that set, and a function that produces the identity. So it should take nothing and produce an element of that set. And so it has to, 000 should be an object with this structure. And so we check 000. Similarly for the source, right? 111 should also be a monoid. And then the third thing should be a homomorphism between those. It should be a function that expects something, an element of the first, an element of the set of values, an element of the first monoid, and produce an element of the second monoid. So that second thing should be, the third element of the triple in position 2 in the array should be a function from the first monoid to the second monoid. So put those all together back into a triple, and oops, that should be okay. And so if we get one of these triples in, we pass all those and get a triple out. So this is a contract for a monoid homomorphism. And then this says how to compose them. And again, I made the mistake of not returning a triple. So there, it's exactly the same as we had here, except we're using mon instead of guard. And so we get this nice category of monoids with monoid homomorphisms between them.